This one, how many moles of electrons weigh 1 kilogram?
Yes,
Yes,
sir.
sir.
This was the question.
Okay. So means in 1 kilogram, how many moles will be there? It actually says in 1 kilogram of electrons, how many moles of electrons will be there. So for that, what you need to do, you need to calculate in 1 kilogram of electrons, how many moles? This is the question. Okay. So you know that this relationship in numbers,
Yes.
you know that 9.1 into 10 to the power minus 31 kilogram is mass of one electron. You know this. Okay. So if it is mass of one electron, then applying the unitary method, 1 kilogram will be equal to 1 divided by 9.1 into 10 to the power minus 31 electrons. These many electrons will be there in 1 kilogram. I am applying unitary method. This masses of one electron, 9.1 into 10 power minus 31. Hence, 1 kilogram will have 1 divided by this mass. But this is number of electrons, not moles. We need moles. So convert numbers to moles. Divide again this by 6.02 into 10 power 23. 6.022 into 10 to the power 23. These many moles will be there. Moles of electrons. When you simplify in the order that given in the options, if you see the options there, it is 9.1 into 6.022 into 10 to the power minus 8. When this 10 power minus 8 will go in numerator, it will become 10 to the power plus 8. These many moles of electrons will be there in 1 kilogram. Any confusion here?
No.
No, sir. It's
Okay. And all those questions which you are not able to answer, and also those questions sometimes you answer, just uh, you don't know the answer, but it is correct. Also, you need to review those questions. So I'm
please
going
explain
back.
the next question as well.
Okay, so in this case, this will be the correct option, the first one. Okay. The options are also jumbled in your paper. So if questions were jumbled, options are anyway jumbled. A, B, C, D, it might be D in your case or C in your case, but here A is the correct answer.
Yes, sir. मेरे में भी एक था.
Right. Any other question?
Yes,
I'm
Sir,
sir.
yes. I'm
Sir,
just
this was
showing
the
you the
question.
questions one by one. Okay.
Okay, sir.
So an alkaloid contains 17.28% of nitrogen and its molecular mass is 162. The number of nitrogen atoms present in one molecule of alkaloid is. These type of questions basically, by percent, 17.28% of nitrogen is there. Means out of 100, it is 17.28. So suppose there is an alkaloid and molar mass is given 162 grams per mole. And it is 17.28% nitrogen in this alkaloid. Okay. Now, nitrogen you will consider as N because in compound, nitrogen will be in atomic form. I told you when I explained the empirical formula that it is nothing but the ratio of the number of atoms or the moles of atoms. For example, HNO3 means in 1 mole of HNO3, there will be 1 mole of nitrogen atoms. Suppose I say N2O5, in 1 mole of N2O5, there will be 2 moles of nitrogen atoms. So one molecule has 2 atoms. It means 1 mole of this compound will have 2 moles of nitrogen atoms. Okay. So 17.28% nitrogen atom means in 100 grams of compound, okay, you have 17.28 grams of nitrogen. This information is converted to a statement. In 100 grams of alkaloid, 17.28 grams of nitrogen. Hence, in 1 mole, and what is 1 mole? 162
6.02
grams.
into 10 to the power.
Hence, in 162 grams of alkaloid, there will be 17.28 divided by 100 into 162 grams of nitrogen. Is this clear or not up to here?
Yes, sir.
Right? So, why I am calculating in 162 gram? Because I know that 162 gram is equal to 1 mole. That's why.
Okay.
So, in 1 mole, this much. It means what is asked. I don't really remember what was the question. What was asked?
Number of atoms. I
Number of
think.
Number of
nitrogen
nitrogen
atoms.
atoms.
Number of nitrogen.
It's 2, sir.
Number of
In
nitrogen
this
atoms. Fine.
case.
So it means when you know the mass of nitrogen, you can calculate number of moles of nitrogen. Number of moles of nitrogen will be whatever mass is there. Okay. This mass 17.28 into 162 divided by 100 divided by
Into
molar
28.
mass of nitrogen atom.
Oh, sir, atom.
Okay. So although I am writing nitrogen here, I should write nitrogen atoms. Logically, these are atoms which are present in molecules. So I will divide by 14, not by 28. These are the
So
moles.
for atom, it's 14, no?
Yes. It means atoms will be whatever number of moles you got multiplied by Na. If number of atoms asked. Okay. So whatever is asked, whether moles asked, if moles are asked, this is the answer. If atoms asked, this is the answer. Conversion from mole to atom will be multiplication by Avogadro number. Na is 6.022 into 10 power 23. If any step is not clear, let me know. So effectively what we are doing, we are saying this is the compound, okay, out of which this much is nitrogen. And these are other elements. This is total. Okay. If we consider this 100, then we say this one is 17.28 and this is 100 minus 17.28. Others, we don't bother about this, but total is 100. 17.28. But it is not just 17.28. In reality, it is 162 in 1 mole. So in 100, it was 17.28. So in 162, if I have now 162, in 162, how much it will be? That's something I calculated here. This much. So I got exact mass of nitrogen in 1 mole. Mass I can convert to moles by dividing by atomic mass, and moles I can convert to atoms by multiplying with Avogadro number. Now tell me if anything is not clear, any step is not clear. So I hope everything is clear then. Okay. So here what is asked? The number of nitrogen atoms present in one molecule. It is in one molecule, not in one mole. Okay. So it means you need to calculate in one molecule, not in one mole. And one molecule you got, the atomic mass will be 162 U only. So I'm just going back, although I have erased that. The question is not in one mole. The question is in one molecule. So you will not multiply by Na, you will not calculate the moles. I'm going back. Okay. Question is, understand the question. The alkaloid contains 17.28% of nitrogen and its molecular mass is 160 U. Okay. So here don't go into moles because you have been asked to calculate in one molecule only. So understand what is the difference here. The question is, you have one molecule. Okay. If I consider this as 100 gram, then 17.28 grams will be nitrogen. This is given, this information. But I want in one molecule. So one molecule I will consider as 162 U. I am not calling it grams. Why? Because now I'm considering one molecule only. And molecular masses in units, molar masses in gram per mole. So we'll apply the same ratio. With same ratio, I will calculate how much will be the atomic mass of nitrogen, total mass present in 162 U. So by unitary method, I'll get this. Say this is X. Okay. This X I'll divide by 14 to get the number of atoms present. For example, this X comes out to be 56. So 56U divided by 14U, atomic mass of one nitrogen will be 4. So this logic I'll apply. So I'll say as 100 grams contain 17.28 grams of nitrogen atoms, not okay. 17.28, this is the ratio. Okay, so this is the ratio, whether you call it in grams or you call it in U, the same ratio will be in U, will contain 17.28 U of nitrogen, because there is direct relationship between gram and unit. That's why. Hence, 162 U will have how many nitrogens? These many nitrogens U. So whatever you get here, then you will calculate number of nitrogen atoms. Number of nitrogen atoms will be whatever you got this value, total U, total units, this much, divided by atomic mass of nitrogen. Understand it what I am saying? I am saying suppose this is the total molecule and there are 5 nitrogen atoms. So if there are 5 nitrogen atoms, what will be the units total? Total will be 14 plus 14 plus 14 plus 14 plus 14. Right? If in one molecule there are total 5 nitrogen atoms, so it will be 14 into 5 means 70 U. So how to get, if I know this value is this. It may not be 70 U, but this is the value I got total. Total is 70 U. How you will get how many nitrogen atoms will be there? You will multiply, sorry, you will divide this 70 by atomic mass of nitrogen and you will get 5. So here you know this value now. This value you know, total. So if you will divide it by atomic mass of nitrogen, you will get how many nitrogen atoms are there. Is that clear? Or if there is any confusion, let me know. Two questions
So
were
what is
there
70?
based on this logic. 70 was an example. That's what I said. I am giving you an example here. If suppose you have 5 nitrogen atoms in a molecule, I am taking an example, not this question. So if there are 5 nitrogen atoms, what will be total value of atomic mass units? 14 into 5, that is 70. Is that clear or not?
Yes.
Example.
Yes,
Now
it's clear.
suppose I don't know how many atoms are there. I know this value 70. So how I can get how many atoms are there? I will divide this value by atomic mass of 14, because one atom has how many units? 14. One nitrogen atom has how many units? Atomic mass of nitrogen is 14. So one has 14. So if total 70, so how many number of atoms are there of nitrogen? Those will be total units divided by units in one nitrogen atom. So suppose total units given to you are 70, and in one nitrogen atom atomic mass of nitrogen is 14, means 14 units. So you will divide 70 by 14, you will get total number of atoms. It is similar to those questions you have done in your 7th, 8th grade, where you are being told that total area is say 64 meter square, okay, and area of one tile is 4 meter square. How many tiles will be there? So number of tiles will be total area divided by area of one tile, 16. Is that clear? Do you remember
Yes.
that? Right? So
Yes.
same logic you are applying here, that total units given 70, for example, 70, and units in one nitrogen atom 14. So number of nitrogen atom will be total units divided by units in one, that is 5. Okay. So in place of 70, you will write these units which are there in one molecule. In one molecule, these many units are there of nitrogen. How we calculated that? Because out of 100, we know out of 100, we have 17.28. So in 162U, how many will be there? Because 162U represents one molecule. 162U is molecular mass. It means 162 units are there in one molecule. Out of those 162 units, 17.28% nitrogen. So we calculated 17.2% of this much. Okay. Another way to look into that is number of units of nitrogen in one molecule, that is 162U, equals to 17.28% of 162U. Is that clear? Nitrogen is 17.28%. So it will be 17.28% of 162 units. So units of nitrogen will be 17.2% of total. That is 17.28 divided by 100 into 162 units. So these many units are there of nitrogen in one molecule. So when you know the units of nitrogen, total units, so number of nitrogen atoms will be equal to total units divided by units in one nitrogen atom. Total units you have calculated this one 17 point, or you can write 0.1728 into 162. Okay, this is equal to 0.1728 into 162 divided by units in one nitrogen atom 40. You will get the answer.
Excuse me, sir.
Yes.
Sir, in these type of questions, sir, when are we supposed to assume nitrogen as N2, or when are we supposed to assume it as atoms? So like how
Never as N2.
Okay, sir.
In molecules, you will always consider nitrogen as atoms. In any molecule, any substance, any element exists in atomic form, not in molecular form. So if what I am saying, for example, if I say H2SO4, it does not mean that here hydrogen exists as H2. No, there are two
Yes.
hydrogen atoms.
Yes,
It does
sir.
not exist that I have two O2. No,
Sir,
it
but
means
then
I
in
have four
certain
atoms.
questions, sir, suppose
Hmm.
hydrogen is written as hydrogen gas, sir, then we know it's H2. But sir, then again in some questions, like if no extra data is provided, then we assume it as a single atom.
In molecules, I said you will always consider it as atom. The constituent elements of a molecule will
Yes, sir.
always be considered as atoms, even if it is written as hydrogen gas. Okay,
Okay,
because
sir.
it exists in atomic form. In all the molecules, every element exists in atomic form.
Yes, sir. Sir, but then suppose in this question, if the compound consisted of N2, but so you are saying that that is not possible. It's only possible when it's single, like single N atom.
Even N2, even if I say N2, it means there are two nitrogen atoms
Yes, sir.
joined together. Okay,
Yes, sir.
so it will exist as N2, but the constituent elements will always be atoms.
So that can always be calculated later, even if we take it as 28 for molar mass.
Yes, if you consider that as 28, then those questions will be different. In these type of questions where you have to calculate the number of atoms in a molecule,
Yes,
okay,
sir.
or number of
Yes.
moles of nitrogen in a molecule, whatever, you will always consider as atomic form
Okay, sir.
of that particular element.
And sir, I had another doubt regarding a certain type of question, sir. In assignment 7, I think the last two questions, sir, it included certain things related to STP, sir, in assignment
Volume.
7.
I know.
Yes, sir. So in that case, sir, first are we supposed to calculate the moles? Then we are supposed to convert it to volume
Yes,
by
you know
initially
the ratio,
considering
right?
it
You
as
know the
mass.
conversion ratio,
Yes, sir.
22.4, right?
Yes, sir. So initially we take it according to mass, and at the very last step we calculate the moles and then convert it, so multiply it
Not
by
necessarily,
22.4.
not necessarily. In few cases, even you can consider, just if it is given 44.8 liters of any gas at STP, you will consider that as 2 moles. You can do
Yes, so that
calculations in
can be
moles,
done initially,
right?
sir.
And then you can
Yes.
convert it into particles or mass if required.
Okay, sir. Okay, sir. Yes,
But
sir.
that depends on the type of question, whether it is easier to do calculations in moles or in mass. So depending on that, you will decide. But it is simply the conversion ratio. You know, 1 mole is 22.4 liters at STP
Yes, sir.
of any gas.
Okay, sir.
So in this case, if you simplify, it will approximately come out to 1.999. It means there will be two nitrogen atoms in this particular case. Now, if I move to next one.
Sir, please do the
Yes,
please do the question this question only, sir.
this question. Okay. Now this is exactly same
Sir,
question.
exactly same, sir. Yes, sir.
Okay.
Yes.
Exactly same question.
Yes, sir. There's no difference, sir.
No difference, right? Just the values will change.
Yes,
Okay.
sir. Just iron, we have to take 56U, which we
Yes.
know, sir.
Yes. Because here also it has been asked the number of iron atoms instead of number of nitrogen atoms, here iron atoms. So the molecular mass is given 67200. It means in one molecule there will be how many units? 67,200 units will be there total. Out of these 67,200 units, 0.33% units will be of iron. Okay, it is given 0.33% of iron by weight. Okay, is there in hemoglobin. So I'm just solving it.
So,
I'm just showing you how to solve it, and it is same thing. Yes.
so can't we apply mass percent here?
Well, mass percent, we are applying mass percent basically, but we are applying in terms of units. Because the question is phrased in that manner. Question says that how many number of atoms will be there of something. For example, here iron. in one molecule. And when we consider molecule, then we talk in terms of units. When we consider moles, then we talk in terms of grams. So when we talk in terms of grams, we can directly apply the mass percent. Okay. So basically we are applying mass percent, but why we are not talking about that? Because in one molecule, we will not be talking about in grams. We will be talking in terms of units. Is that clear what I am saying? Okay.
Okay, sir.
Right. Otherwise, you will get the same answer. Their answer will not be different. The absolute value will be same, because you know that if I say it is 67,200 units in one molecule, it means the molar mass is 67,200 grams. So the absolute value will be same. To understand this question, I am solving this question because if there is any confusion in previous one, you can understand in this one. So here it says that if it is 100 units total, out of 100 units, 0.33% means 0.33 units will be of iron. If total 100 units hemoglobin. Then 0.33 units are of iron. It is given 0.33%. Then you need to calculate if this is not 100 units, this is 67,200 units of hemoglobin. Then how many units will be of iron? Okay. So you can apply direct proportion method. So number of units of iron in one molecule of hemoglobin will be 33% of molecular mass of hemoglobin. Molecular mass is represented in terms of units. How many units total? 67,200. It will be 33% of, sorry, 0.33, not 33, okay? 0.33% of means 0.33 divided by 100 of means multiplication, total units in the molecule. Means it will be 0.33 into 672 units.
Sir, can you put 56 here itself, sir? The calculation will directly become easier.
No, because
So
you
like,
have to now calculate the number of atoms separately, right? You got the number of units of
yes.
iron. So here you
Yes,
can't
sir,
put
yes.
56. Okay. So you
Okay.
got the number of units of iron. So number of atoms of iron will be total number of units of iron divided by atomic mass of iron, or you can say units in one iron atom. That is atomic mass of iron. What is atomic mass of iron? It is how many units are there in
56.
one
Yes.
atom, 56. So you will write 0.33 into 672 divided by 56. When you calculate, I think it should come close to 3.96, which is actually 4, which will give you 4.
So 56 cancels 672 by 12.
Yeah, it will give you 3.96,
Yeah, sir.
which will
Sir?
approximately be equal to 4. So it means there will be 4 atoms of iron in one molecule of hemoglobin. Yes.
Sir, can you please share the recordings of previous classes?
Those are already there on website.
Okay, sir.
Clear? Any step not clear, let me know. So you need to be very clear that here calculations are in terms of units. In one atom of iron, there will be units equal to its atomic mass. So one iron atom will have 56 units. So if we know total units, we can divide that by 56 to get the number of iron atoms. Similar to number of tiles equals to total area divided by area of one tile. So total area here, total number of units of iron divided by area of one tile means number of units in one iron atom, that is 56. That is very important to understand that logic. So that mathematical part has to be strong. And in chemistry, you will again and again use unitary method, which is nothing but this formula I am talking about. That is unitary method actually. So have command on unitary method. I'm going back to the questions. So here B will be correct. Okay, 4 iron atoms will be there in one molecule of hemoglobin. Now the third one, 2 grams of oxygen contain number of atom equal to that contained by. This one is easy. I don't think anyone should have any problem, but still if anyone has problem, let me know. 2 gram of oxygen, basically you know that 16 gram of oxygen will have how much? Because that is the atomic mass of oxygen. Atomic mass of oxygen is 16, 1 mole. So 16 gram of oxygen will have 6.022 into 10 power 23 atoms. 2 grams will have 6.022 into 23 divided by 8. Because this is 1/8 of 16.
Answer is 4 gram sulfur.
Yes, correct. Okay.
4 by 32, so
Yes.
it gives
And
us
in
Na
such
by 8.
cases, if you answer, if you see the question and think smartly, you don't need to do calculation. You don't need to do all calculations. As I said, 6.022 into 10 power 23 divided by 8. You don't need to do that.
So
Think
rather
what
than
I'm saying.
calculating, we'll just represent the Avogadro number by Na and see the fraction to be the same.
Yes, basically you need to apply the formula that it is proportional to something. Okay, it is proportional to something. If you think in that direction, then it will be easy to answer these type of questions. So just think about it before I tell you that how to get the answer, not doing so much calculation. What could be the relationship? Remember, it is mass given and we are talking about atoms. And mass can be easily converted into molar mass. So number of moles, you know, 1 mole is equal to 6.022 into 10 power 23 means Na. So there is a direct relationship. And 1 mole in terms of mass, you can write given mass upon atomic mass. Okay. So just explaining that. So the relationship between mole is this. Mole Na particles, Na atoms. Okay. Now see the question. What question says? Question says 2 gram of oxygen contain number of atoms equal to. And whenever we are talking about 2 gram of oxygen, okay, consider atom. Don't consider molecule. Because answer will be same. If you consider O2, you will consider the molar mass as 32. If you consider oxygen, you will consider atomic mass as 16. And obviously atomic mass will be half of molar mass. So it will be same thing. Because we are talking about atoms only, keep the calculations in atoms only. You are talking about 2 grams of oxygen contain number of atoms equal to that contained by. Equal to that means atoms. Here that means atoms, not molecules. So 2 gram of oxygen contain number of atoms equal to that contained by Something means atom. So here we are comparing atoms and atoms. Keep the calculation simple, everything in atomic form. So here moles of oxygen in atomic form. If 1 mole of oxygen atoms or any atoms will be Na atoms. And what is written as mole? If you write in terms of mass, 1 mole is equal to mass into molar mass equals to Na atoms. Okay, so it is actually 1 molar mass in gram. 1 mole is molar mass, or you can, sorry, given mass upon molar mass. So I'm writing in short, just given mass upon molar mass, moles. Okay. And if you want to convert it to atoms, you need to multiply that by Na. Now come to the question. It says 2 grams oxygen atoms means 2 divided by 16 Na. Don't write the value of Na. Don't do any calculations. Okay. Now you got the number of atoms. 2 by 16 Na. Now if you consider sulfur, what will be the atomic mass of sulfur? 32. Something multiplied by 30 divided by 32 into Na. Now tell me, is that clear or not? Both atoms are same. The question says both atoms are same. I calculated the number of atoms, didn't do calculation. I have written Na only. Now the option given, one of the options given was sulfur. So for that sulfur, I didn't know how much amount will be required. So that's why I said, okay, given mass is X, but atomic mass of sulfur I know. Atomic mass 32. I'm not considering molecular mass, atomic mass. Na. Na got cancelled. X I got 4. So you just compare the two sides without doing calculations. Most of the things will get cancelled out. So I'm going back to the question so that you can understand what I am saying. Here, one of the options was 4 grams sulfur. Now, because I clearly got the idea, oxygen has atomic mass 16, sulfur has 32, so obviously it will be 4 grams. So I considered 4 gram as first example. But if you consider hydrogen, for hydrogen, how many grams will be required? So for hydrogen, apply the same logic without doing much calculation. For hydrogen, you will say X gram, but what is the atomic mass of hydrogen? 1 into Na. Na got cancelled. In this case, X will be 2 by 16, that is 1 by 8, which is certainly not 0.5. In the question, it was given 0.5 grams. So that option is not correct. Any confusion in this case, you need to let me know if you're not getting any point. What I am comparing? I am comparing the number of atoms in both cases. Okay, because the question says both will have same number of atoms. Question says 2 grams of oxygen contain number of atoms equal to that contained by. So I am comparing the number of atoms of oxygen with the number of atoms of other things. So 0.5 grams of hydrogen will not have same number of atoms because I didn't get X as 0.5. In second case, sulfur case, I got X as 4 grams. It means B is correct. Now why C is not correct? I'm just explaining C once more and then I'll move to next question. Nitrogen. For nitrogen, if I want to calculate for nitrogen, the atomic mass is 14. So number of oxygen atoms I have already calculated. For nitrogen, it will be, say, X is given mass divided by 14 will be number of moles multiplied by Na. Na got cancelled. X I got 2 into 14 divided by 16. 14 by 8 is certainly not 7 or 0.7, whatever was given there. Okay, so it means C is also not correct because it will not be those many grams given in the question. In question, it was given 7 gram of nitrogen. However, we got 14 by 8, which is not 7 gram. So that's how you will calculate. One more thing to make it further easier, and that's I didn't tell you because you will get confused. And you should know that the atomic ratio is equal to molar ratio. So if you can understand that, you can simplify it even further. Atomic ratio is equal to molar ratio, so you don't need to convert it into atoms. You can just say number of moles of oxygen equal to number of moles of unknown atoms in options, and here you have oxygen atoms. Okay. So moles of oxygen atoms should be equal to moles of unknown atoms because this is just a multiplication of Na will get cancelled. Okay. So if atoms are same, moles will also be same. Suppose you have atoms X here, say N here and N here. So what will be the number of moles divided by Na? Divided by Na. So if atoms are same, their moles will also be same. So in 2 grams, number of moles 2 by 16. Now consider sulfur, hydrogen, nitrogen, or whatever was there. Okay. It is given for hydrogen, it was given 0.5. 0.5 divided by 1. It is not equal to 1 by 8. For sulfur, it is given 4 divided by atomic mass 32. Yes, it is 1 by 8. So it means this is the answer. Nitrogen, it was given 7 divided by 14 is 1 by 2. It is not 1 by 8, not the answer. Okay. So this is another way easily to get the answer. Number of moles should be equal. So whatever is given, convert that to number of moles in the options. If that comes out to be equal to number of moles of oxygen atom of 2 grams, that will be the correct answer. Now tell me, is that clear or not?
Yes,
Or
sir.
if still there is any confusion, then don't hesitate. At which point confusion is there? Oh, good. Next question. Is there any confusion in this one? Which of the following remains contains highest number of atoms? These type of questions we have done quite a few times, and
Such deep.
yes, it will be the one highest which will have the lowest atomic, lowest molecular mass or a lot of atoms in the molecule. So the question you need to understand, the question is talking about number of atoms, not number of molecules. Okay, number of atoms. So first option is about 1 gram of nitrogen. So nitrogen, one molecule will have 2 atoms. Again, if you understood the concept, it will be very easy to get the number of atoms in 1 gram, whether you consider it as atomic mass or molecular mass. I'm just explaining, and a lot of students remain confused that why we are sometimes considering atoms or we are considering something molecules. So first option says 1 gram of nitrogen. Whether you consider the atomic mass or you consider molecular mass, you will get same answer, same number of atoms in 1 gram of nitrogen. Just look here if you are still confused. I have 1 gram of nitrogen. I'm writing here as nitrogen. I'm not writing N or N. Suppose I consider it as 1 gram of nitrogen atoms, or I consider it as 1 gram of nitrogen gas molecules. Okay? What I'm going to show you that it will have exactly same number of atoms. So here moles will be given mass divided by nitrogen is in atomic form, so atomic mass 14. Here moles will be given mass upon molar mass of nitrogen 28. These moles are of nitrogen atoms. These moles are of nitrogen gas. Okay, now calculate the atoms. Atoms will be number of moles into 6.022 into 10 to the power 23. Remember, these are moles of nitrogen atom. Now I am calculating number of atoms. Here, moles of nitrogen gas means molecules. Hence, number of molecules will be number of moles into 6.022 into 10 power 23. These will give you molecules. Hence, atoms will be 2 times number of molecules. Why? Because in one molecule you have 2 atoms.
Yes.
So whatever molecules you have, atoms will be 2 times. That is 2 into 1 by 28 into 6.022 into 10 power 23, which will give you 1 by 14 into 6.022 into 10 power 23, which is exactly same as you got here. So that's why I am saying that if calculations are, if the question mentions atoms, calculations must be in atomic form. That will save time in calculation. Otherwise, you will have to divide it, multiply it, okay, and it will require more time. So the question here, which of the following contains highest number of atoms? So highest number of atoms depends on 2 factors. First factor is atomic mass or molecular mass. Okay. And second factor is how many atoms are there in one molecule. So if you see the fourth option, 1 gram of propane, propane C3H8, 3 plus 8, 11 atoms are there in one molecule. It means whatever number of molecules you get in 1 gram, you will have to multiply that by 11 to get the number of atoms. Okay, suppose you get 60 molecules of propane, suppose. So 60 molecules of propane means one molecule has 11 atoms. 60 molecules will have 60 into 11, that is 660 atoms. So it means D is a very good candidate for answer. So you will first check for that one. So you will focus on 2 things. First, the atomic mass or molar mass should be very low. That will have greatest number of atoms. And again, focus, secondary focus should be there. How many atoms are there in one molecule? In this case, fourth one, there are quite a few, 11 atoms in one molecule. So that can be candidate even though C3H8 has high molecular mass. But one molecule has a lot of atoms. That's why. So 1 gram of nitrogen will be 1 divided by atoms. We are talking about 14 into Na. Okay. 1 gram of water. 1 gram of water, how many molecules will be there? 1 divided by 18 into Na will be molecules. Multiply that by 3 because H2O means there are 3 atoms, 2 of hydrogen, 2 of hydrogen, 1 of oxygen. Then 1 gram of silver, atomic mass is 108. So very high atomic mass, 1 divided by 108 into Na. Then 1 gram of propane. So I'm just considering everything, nitrogen, water, silver and propane, and calculating the number of atoms. If this concept is not clear, let me know, anyone. Don't hesitate. If anything is not clear.
Can you repeat?
Okay.
Sir, can you explain it again?
Yes, nitrogen, water, silver, and propane. Okay. One gram nitrogen, 1 gram water, 1 gram silver, 1 gram propane. Okay. Question is, which one will have greatest number of atoms? So 1 gram, 1 divided by 14 number of moles. Okay. Given mass upon atomic mass will give you number of moles of atoms. Why I consider 14? Because I am talking about atoms. I need atoms. Multiplied by Na. Otherwise, you could have done 1 by 28 into Na. These would have been molecules. If you consider N2, so 1 by 28 into Na molecules into 2 atoms, because one nitrogen molecule has 2 atoms, you will get exactly same thing. So 1 by 14 Na atoms. Here 1 divided by 18 into Na molecules. Because 18 is molecular mass of water whole, not of hydrogen or oxygen only. So these many molecules. How many atoms? 1 by 18 into Na into 3. Because one H2O molecule has 3 atoms, 2 hydrogen, 1 oxygen. Means 1 by 6 Na. It was 1 by 14 Na. Now 1 gram silver, given mass upon atomic mass 108 moles into Na. So till now, this is the candidate. 1 by 6 Na is greatest. Out of 1 by 14, 1 by 6, 1 by 108, 1 by 6 is greatest. Now come to propane. 1 divided by molecular mass of propane will be 12 3s are 36 plus 8. Is this
Sir?
visible or not? My screen is visible or not?
Yes, sir, it's visible.
Okay.
I wanted to ask something.
Yes.
Sir, after calculating the number of moles, shouldn't we multiply it with 6.022 into 10 to the power 23?
Yes, that's what I am doing. Na is Avogadro number 6.022 into 10 power 23. Na
आपने
is Avogadro number
okay,
equal
sir.
to 6.022 into 10 power 23. So instead of writing every time
Okay, sir, समझ गया.
6.022 into 10 power 23, I am writing Na. So here it will be number of moles given mass upon atomic mass. Moles multiplied by Avogadro number will give you number of atoms. Now here, because it exists in the form of molecules, I will first get the number of molecules. If I do given mass upon molar mass here is 44. Okay. How I calculated 44? 3 into 12. 12 is atomic mass of carbon. 1 is atomic mass of hydrogen. So 3 into 12, 36. 8 into 1, 8. 36 plus 8 will give me 44. These are the number of moles of C3H8. I will multiply it by Avogadro number. These many molecules of C3H8. But one molecule has 11 atoms. 3 plus 8 equals to 11 atoms. 3 of carbon, 8 of hydrogen. It means atoms will be how much? 1 by 44 Na multiplied by 11. That is 1 by 4 Na. Now out of 1 by 14 Na, 1 by 6 Na, 1 by 108 Na, and 1 by 4 Na, which one is greatest?
Sir, 1/4.
1 by 4 Na. So it means in case of propane, 1 gram of propane, there will be maximum number of atoms.
Sir,
Hmm.
so what is the difference between 1 mole and Avogadro number?
Okay, Avogadro number is actually 1 mole.
Yes, sir, because both values are 6.022 to 10 raised to power
Yes.
23.
Okay, so in terms of particles, Na Avogadro number is moles in terms of particles. But otherwise, if we consider in terms of volume, in terms of mass, it will be different. So mole can be represented in different terms. If it is in numbers, then it is Avogadro number.
Okay.
Now the next one. This. The total number of electrons present in 3.2 gram of methane. This one I think is easy. Most of the students have done it correctly, but still if you have any problem, let me know. You need to calculate number of electrons. So you will get in one molecule how many electrons are there in methane. Carbon has 6 electrons, hydrogen 1 electron, but there are 4 hydrogens in methane, CH4. So it is simple in terms of you need to calculate the number of molecules. Calculate the molecules. But one molecule has 10 electrons. One molecule of methane.
Yes, sir.
Carbon has 6. Hydrogen has 1 electrons. 4 into 1, 4. So 6 plus 4, 10 electrons in one molecule of methane. So calculate the number of molecules of methane and multiply that by 10. Those many electrons will be there. And you know how to calculate the molecules now. By now, it should be very easy question for you. Okay. 3.2 grams means 3.2 divided by molar mass of methane, which is 16. This one we have done. Number of molecules present in 1 milliliter of water. This is something very easy because 18 milliliter will have 6.022 into 10 power 23. So 1 milliliter will have how much? That is something you need to calculate. Okay. Unitary method again. Why I am saying 18 milliliter has 6.022 into 10 power 23? Because 1 mole of water is equal to 18 gram. That is the molar mass of water. So molar mass is equal to 1 mole. And 1 mole is 6.022 into 10 power 23. 18 gram of water will be equal to 6.022 into 10 power 23 molecules of water. Okay. So 18 milliliter will have same because density of water is 1 gram per ml. So if 18 grams will have 6.022 into 10 power 23 molecules of water, 18 milliliter will have the same amount. 18 gram is equal to 18 milliliter of water. Density is 1 gram per ml. Hence, 1 milliliter of water will have how many molecules? It will be 6.022 into 10 power 23 divided by 18. And you will get answer 3.346 into 10 to the power 22. Okay. Still, if there is any problem, you can ask. Now the next one. 0.6 grams of carbon was burnt in air to form CO2. The number of molecules of CO2 introduced into air will be. So it is simple. C plus O2 will give you CO2. 0.6 grams, you have been asked how many molecules of CO2 will be produced. I'm just calculating it or showing it very quickly. If you don't get it, let me know. C plus O2 gives you CO2. And stoichiometric calculations, you know that 12, it is 1 mole, okay? 1 mole of carbon gives you 1 mole of carbon dioxide, means 12 grams of carbon gives you 44 grams of carbon dioxide. Molar mass of carbon, atomic mass of carbon is 12, molar mass of carbon dioxide is 44. Hence, 0.6 grams will give you how many grams? And then you need to convert those to the number of molecules. Okay, number of molecules. How can you convert that to number of molecules? To moles. Okay, rather keep it 1 mole. That will be simpler. Because you have been asked about the number of molecules, it will be easier to convert moles to molecules. So 12 grams of carbon give you 1 mole of carbon dioxide. Just let me know whether it is clear or not, what I am saying.
Yes, sir.
This ratio, okay? Hence 0.6 grams will give me 1 by 12 into 0.6 moles of
Yes, sir.
CO2. I'm just applying unitary method. And these moles I can convert to molecules. It will be 0.6 divided by 12 into 6.022 into 10 to the power 23 molecules of carbon dioxide. Moles to molecules, moles to particles, you need to just multiply by Na. Conversion chart is very important. Okay. Means it will be 1 by 20 means 3.011 into 10 to the power 20 molecules of carbon dioxide. Don't just sit back. I'm getting a feeling that quite a few students are just sitting back listening to me. Okay. So here answers are confusing. The first option is 3.01 into 10 power 23. That will not be the answer. 3.01 into 10 power 22 will be the answer. Yes. Correct, Anna. C part will be correct. Now the next question. Which of the following has maximum mass? So this is something you need to convert moles to mass. Convert these to moles if not given and multiply by molar mass. So this one is at least easy what I am considering. So first one will be
So it's option A,
0.5
I
mole
think.
Sir,
multiplied by
sucrose.
Sir,
three-
sucrose.
yes. So 0.5 into molar mass of sucrose. Molar mass of sucrose, I told you to remember 342. So 342 multiplied by 0.5 means divided by 2, that is 171. And 22.4 liters of nitrogen at STP 22.4 liter will be 1 mole of nitrogen. 1 mole of nitrogen will be 1 into 28, that is 28 grams only. The first one is 171 gram, then 28 gram. 1.2 mole of silver. Silver is 108. 108 into 1.2. Okay, so it will be around 129. Is still not 171. Less than 171. A part. Then 1 mole of H2 gas. 1 mole of H2 gas. 1 into molar mass of hydrogen 2 is only 2 grams. So A will be the correct answer. Now the last question, I think after that I will not be able to take any question. The last one, number of atoms in 558.6 grams of iron. This is very easy, given mass upon atomic mass. So I'm just skipping it. 40 gram of caustic soda contains, the caustic soda is NaOH, sodium hydroxide. How much sodium or hydrogen? Okay. Now, if I see it is given sodium, hydrogen, O2 and N2. Just look here. If I say NaOH, sodium 23, oxygen 16, hydrogen 1, total 40. It means 1 mole is 40 grams. And it means 40 grams will have 23 grams sodium, 16 grams oxygen, and 1 gram hydrogen. 23 grams sodium, 16 gram oxygen, 1 gram hydrogen. So if it is so, it is obviously not 4 grams sodium. So that option is not correct. Now come to 16 grams of oxygen and 1 gram hydrogen. 16 grams of oxygen, 16 grams and 1 gram of hydrogen. So 1 gram of hydrogen will be how many moles? 1 divided by
1.
atoms. Okay, B part says atoms of hydrogen, means atomic mass is 1. So 1 divided by 1 means 1 mole, and 1 mole will be equal to 6.02 into 10 power 23 atoms. So B seems correct, but still consider C and D. We have 16 grams of oxygen, means how many molecules? C part does not talk about atoms. C talks about molecules. So if you first calculate the number of atoms in 16 gram, number of atoms will be 16 divided by 16, that is moles into Na. So it will be 6.022 into 10 power 23 atoms. How many molecules will be there? Divided by 2. Is that clear or not what I am saying? If it is given
Yes.
6.022 into 10 power 24 molecules of O2, here it is given. Why it is not correct? Because 16 gram of oxygen atoms will have how many moles of atoms? 1 mole of oxygen atoms. Because here we are talking about oxygen atom. I told you always in molecule, the constituents are in atomic form. And 1 mole will be equal to 6.022 into 10 power 23 atoms of oxygen. It means how many molecules? 6.022 into 10 power 23 divided by 2 molecules. Because 2 atoms will be equal to 1 molecule. Okay. So if 2 atoms equal to 1 molecule, 4 atoms will be 2 molecules, means half. So half, applying unity method. So it is not 6.022 into 10 power 24, not the answer. Correct answer is the second one. This one, 6.02 into 10 power 23 hydrogen atoms. The last part is 22.4 liters of N2, which is actually 1 mole of N2. Okay. And caustic soda does not have nitrogen. Caustic soda is NaOH. Okay. So that's why D part you don't need to consider. B part is correct, 6.02 into 10 power 23. Any confusion? Anyone? Okay. Now next Sunday I'll schedule an extra class. Keep your questions in assignment which you are not able to do handy. So that session will be specifically to clear the doubts related to assignments. There will be assignment, consecutive assignment today, tomorrow, day after tomorrow, 3 assignments you have to do. And on Sunday, I'll discuss those questions.